This photo is from a sample from the mound vein, and it's a beautiful example of coliform banding that we see in the epithermal veins on the American Creek project. This is our disclaimer. As an exploration company, I will be making forward-looking statements. MountainBoy is focused in the Stewart area. The company has several projects, and in this presentation, I'm going to be focusing on American Creek. The American Creek project is located approximately 20 kilometers north of the town of Stewart, where there's a deep water port that currently ships ore from several deposits in the area. The project is road accessible off of Highway 37A, and the transmission line that powers Bruce Jack occurs just to the southeast of the claims. The property as it is today was consolidated by the president's Lawrence Rolston, who saw the potential for the project to host a larger scale system. This amalgamation really allowed for the geological team to look at the bigger picture and start putting the different areas of known mineralization into that bigger picture. Going into the 2020 field season, we had a lot of questions. At the top of the list, we wanted to know the age of the host stratigraphy. There's almost a 1.5 kilometer vertical section on the property, and we wanted to know if we could constrain the age of the stratigraphy and the timing of its deposition. What is the age of the American Creek intrusion? We were very interested in the age of the two feldspar porphyry that we discovered in 2019. Part of our initial model was that this unit could potentially be the heat source for the epithermal mineralization. Of course, we wanted to know the age of mineralization and what were the controls on the mineralization. One aspect about the geology we were very curious about was how much of an influence did the lithological units have on controlling the veining and where the veins were deposited? How does the mineralization at the Wolf Moon showing fit into the picture? Well, based on initial mapping, we speculated that the Wolf Moon showing was a younger and different phase of mineralization than the epithermal style observed at the MountainBoy mine. Mapping in and around the Wolf Moon zone, we observed flow banding and breccias within a feldspar ferric coherent unit that we interpreted to have all the hallmarks of a dome feature. And structurally, we wanted to know how regional scale structures affected the property geology. So that were our big questions going into the field season. And now I'm going to show you the list of things that we did to try and start to answer them. So we designed a field program to answer as many questions as we could. We produced a revised property map. We have uranium zircon ages for the volcanic units. We have a lead isotope model age for the mineralization. We have an amazing digital elevation model from the LiDAR survey. We did a 9 kilometer IP survey over the Wolf Moon zone. We continued prospecting and sampling, and finally in the fall we drilled. In 2019, this was our map. This is where we started. Our initial map was based on regional BCGS mapping and refined with airborne geophysics where it was available on the property. Then, with limited boots on the ground, we further refined it. We recognize that the property has a lot of characteristics on it that make it a compelling target. On a regional scale, the property is bound by two major north-south oriented faults. Nelson and Kaiba in 2014 found that in the KSM and Bruce Jack area, north-south faults represent deposit controlling basement structures. So we're testing that idea on our ground. We know that over kilometers across the property, there are several mineralized showings with limited amount of work done on them. And we're well aware that just a few kilometers to the west, there is a past producing mine looking to go back into production. So in my next slide, I'm going to show you a cartoon section through A prime, which is approximately 12 kilometers long. In this slide, we're looking at our cartoon cross section, and in the section, we're looking towards the northwest. So on the eastern part of the cross section, there's a topographic low, and that's where the American Creek Fault and American Creek drainage are. And it also roughly represents the axial plane of the American Creek anticline and happens to be the site of emplacement of the two feldspar porphyry unit. Based on initial mapping, we knew that the epithermal veins occurred on the eastern side of Bear River Ridge. We knew that they were variably dipping, often shallow, and we knew that they were hosted in the Betty Creek Formation. The Betty Creek Formation is overlain by younger Mount Dilworth and Quaff formations on the western side of Bear River Ridge. On the furthest western part of this section, we've drawn in Big Missouri, which is partly structurally controlled, and the premier porphyry is thought to be a heat source for that deposit. And one of the comparisons that we've been making is that Mountain Boy could potentially be a Big Missouri or premier analog. So this is our updated geology map. I'm sorry my face covers part of the map. It's green underneath it. In this updated map, contacts mapped or inferred were based on the fieldwork conducted between 2019 and 2020. Property scale mapping in 2020 was led by Esther Bourdet, and in this map, contact and fault relationships and geometry and units were further interpreted and refined using geophysics and the LiDAR that we flew this past summer. Unit descriptions were refined also based on petrographic observations, and we're currently waiting on our lithogeochemistry results to help refine our field terms for the units on the map. So very simply, on the east side of the property, we have older stratigraphy, which youngs to the west. The dark green unit represents the Betty Creek Formation, which consists of andesitic flows and a thick package of volcaniclastics. And at the height of land along the ridge, we mapped a significant package of Mount Dilworth Formation, which consists of flows, tuffs, and sediments. And these units of the Mount Dilworth Formation are often in thrust fault contact with the thinly bedded mudstones of the Quack Formation. So this entire package of rocks has been affected by the skeenofold and thrust fault deformation, and the different lithologies partition strain quite differently. So the mudstones of the Quack Formation, for example, are tightly folded, whereas clear evidence for folding in the volcanic unit is much harder to come by. So from our detailed mapping, we've produced a structural interpretation that includes Jurassic to late Cretaceous sinistral transpression. And that resulted in northwest trending thrust faults and folds and north to northwest striking shears. This was followed by northeast-southwest extension, which resulted in northwest trending dikes, which manifest mostly on the southwestern part of the property down the yellow unit. And lastly, there's evidence for east-west extension resulting in north-south trending dikes. So I'm going to show you cross-section A next, which is at the center of the map, and it goes from west to east. In this section, we're looking towards the north. The American Creek drainage is on the east and Long Lake is to the west. The MB Silver Mine is just north, but from this section you can see that it roughly plots at the contact between this mossy green volcaniclastic unit and this darker green andesitic unit. And unfortunately, my head is covering the American Creek intrusion right down here in the drainage. Cross-section B prime is looking towards the northwest. The amount of faulting and fault offset really becomes evident in this section, and how much offset there is and whether we're looking at a flower structure is something that we plan on spending more time on. We're also not sure about how we've depicted the folding in the west. we're not so sure that the volcanic units really are in this kind of contact with the quark. And we actually aren't sure with how we've drawn in the two feldspar porphyry on the east side. We don't know if it's been truncated by the American Creek Fault or not. So now that we've looked at the property in plan and in a couple sections, I'm going to show you some of the isotopic data that we have for 3 of our different units. This sample is from the American Creek intrusion, the 2 feldspar porphyry we discovered in 2019. It's the pink unit on the map with the star on it. We have interpreted this unit to be a subvolcanic intrusion, and zircons from this unit have provided an early Jurassic age of 185 million years. And if we're considering this unit to be a potential heat source for the epithermal mineralization, then something has potentially got to give in our model. This sample is at least 5 million years younger than the age of the Texas Creek Plutonic Suite and its related premier porphyry. So several possibilities come from this data, and I'll put forward 2 possibilities. One possibility is that the subvolcanic intrusion has nothing to do with being the heat source for the epithermal mineralization on the property, and the mineralization is related to an older unmapped unit that we just haven't found yet. Or the mineralization is related to this 185 million year old unit, and the mineralization falls into what Bram Van Straten describes as the 5th metallogenic period in the Golden Triangle. So this is a look at the sample in the field and in a hand sample and thin section, and these are some of the zircon, and you can see on the Concordia plot all the data plots pretty nicely to give it a very robust age. A galena sample was taken from the Mountain Boy mine and was analyzed to provide a lead isotope model age. So this graph is modified after Godwin and et al. And in the 1991 BCGS fieldwork paper, Godwin, Gabides, Aldrich, and others collected galena samples from numerous deposits in the Golden Triangle. And their major finding was that the lead isotope data created a bimodal population. So they had 2 clusters, and the 2 clusters represented one group where mineralization occurred during the Jurassic, and another cluster where the data and mineralization occurred during the Paleocene. So deposits that make up the points here in the Jurassic cluster include the Torbit Mine and Dolly Varden, Big Missouri, Silback Premier, Scotty Gold, Grand Duke, Johnny Mountain, Sulphurettes, Eskay Creek, and here in the pink is the galena sample from the MB mine. We plan on analyzing a galena sample from the Wolf Moons showing also to test our hypothesis that it represents a younger phase of mineralization. This is a second sample we did uranium lead zircon geochronology on. This sample was taken from a unit that we have interpreted to be part of the effusive facies of a dome feature on the west side of the property. So it's where the red star is on the map, a little bit to the south. This is what the sample looks like in the field. And this unit is a coherent feldspar-ferric, locally glassy and crystalline with a spherolytic ground mass. Not too far from where this sample was taken, along the continuation of the outcrop, the unit shows flow banding. The sample similarly yielded an early Jurassic age of 183 MA, so 2 million years younger than our American Creek intrusion. So now we've partly constrained the age of the stratigraphy on the property, and we have fossil samples from the youngest stratigraphy in the Quack, and we still need to tease out the details on the andesites and the volcaniclastic part of the Betty Creek Formation. This photograph on the left is of the track-mounted drill we used to test the 4B's target from the road. This road that you can see in the photograph, you can actually see in the map also in yellow, and it goes past the Cameron Adit as you go up the slope, and as you go down and towards the south, it'll take you out to Highway 37A. And if you go north, we cleared it. It was a pre-existing road, and it takes us almost to the northern limit of the claims. So that'll give us much better access to the slopes of the east side of the property for next year's field work. In this map on the right, the black lines are the drill hole traces from the 2020 field program, and the gray dots are historic and future drill collars and traces. And now that we've looked at the geology for the property, I'm going to show you a little more specifically the areas we drilled, starting with the Wolf Moon, which plots down here in the southwestern corner of this map. So the Wolf Moon zone was discovered in 2019. As I said before, we believe it demonstrates a second mineralizing event on the property. We've interpreted it to be younger and structurally controlled. Mineralization so far, we've mapped over 450 meters, and it's open on all directions. Surface samples have come back with very favorable results, 28 grams per ton gold and over a kilogram silver. We tested this zone with 2 different drill setups, about 250 meters apart, and 5 drill holes. So the drill holes did intercept mineralization consisting of minor galena and chalcopyrite and sphalerite associated with quartz veins, and significant faulting along graphitic slips. Lithologically, we intercepted a lot of pyroclastic units and interbedded with coherent units. So here's a look at the IP geophysics on the Wolf Moon zone. Both of these plan maps are plotting at 50 meters below surface. Drilling on the Wolf Moon was guided by mineralization on surface, as well as chargeability, which is in the map on the left, chargeability highs, and resistivity lows. So basically, we've interpreted that a lot of the felsic dikes that we had mapped on the Wolf Moon zone correlated to resistivity lows. And we often saw mineralization along the margins of the dikes. So we interpreted that there was a pre-existing plane that either the dikes or the mineralization was exploiting. And like I mentioned before, in our initial mapping, we were speculating that there was a dome feature in the Wolf Moon area. And in the next slide, I'm going to show you a few field photos that support our idea. We were encouraged to find evidence for hot emplacement because it helps support our dome hypothesis for that part of the property, and active volcanism is a great heat source for mineralization. So here in photo A, we're looking at large juvenile clasts in a welded tuff. And in photo B, similarly, we're looking at a welded tuff in ductile deformation with an andesitic flow So the andesite is the underlying darker unit. And in photo C, we're looking at an andesite breccia, so the breccia andesite are the clasts, and the gray-green unit is a green welded ash tuff. And this is a thin section up on the top right corner for this unit. Now we'll zoom over to the east side of the property where the epithermal style mineralization is. So in this map, the black traces again are the 2020 drill hole traces. The gray traces are the 2006 and 2011 drilling. The green lines are the underground workings, and there's about 750 meters of underground workings that we plan on exploring next season. And what we managed to do was extend the high-grade vein zone over 80 meters. The Upper Ruby is a brand new discovery. We tested the 4B zone, and we have another pad built to kind of go at this target from another angle. So now looking a little more closely at the high-grade vein in the MB silver mine. So we set out to drill 3 holes on this target. 2 of the 3 holes intersected the zone, and right now this system is still open in all directions. The MB silver mine area has 8 mapped veins and 5 historic adits. Both holes intersected coherent feldspar-ferric andesite flows and variably matrix-supported volcaniclastic rocks. These 2 units were often observed in fault contact with each other, and the veining and mineralization seems to be associated with the volcaniclastic unit. Looking at grab samples and photographs B and C, they're from the 4B's target, and we can see semi-massive mineralization that is associated with vein brecciation and what looks like multiple pulses of mineralization. And in photographs A and D, we can see more of the beautiful coliform texture that suggests episodic veining at a near surface condition. The Upper Ruby drill target, in the photograph on the right, you can see the rig, and it was starting to get pretty cold with the snow. So this was a new zone that Andrew Wilkins found, and based on the mineralization we saw on surface, we decided to drill test it. This target area has been traced over 115 meters on surface and 52 meters into the hill. The mineralization is thought to be separate but related and a parallel zone to the mineralization at the high-grade vein. So this drill hole actually intercepted the same lithological units as the 2 holes in the high-grade target, as well as quartz baric carbonate veins hosting some sulfides. So further north on the property, we have the Dorothy veins, and to the north there's another 15 vein occurrences that have been chip sampled but have never been drill tested. So that's where we plan on stepping out to in the upcoming season. And this is my summary slide. So this photograph is one of my favorite photographs of the American Creek project because we're on the east side of the slope, and this is all Betty Creek, and up in here there's some mega conglomerates, huge blocks, and then you get sand-sized, well-bedded feldspar-ferric units. And here, you can just see some warping and folding in these volcanic units, and it's a bright, beautiful volcanic package. And then here on the left, these 2 schematics are from work by Danny Aldrich, and I think we have pretty compelling evidence that can at least put us into the proximal zone of a volcano. So here, where he's got a mixture of lava and pyroclastic flows and the dome. However, with our two feldspar porphyry and our subvolcanic intrusion, maybe there's some evidence that we might be closer to a vent source. In this lower diagram, Aldrich draws Mount Dilworth, which is the actual Mount Dilworth is to the north of us, and he interprets it as an andesitic volcano. And to the east on this diagram, Bear River Ridge is a thick succession of the volcanic member of Stuhini rocks, and well, that just hasn't been what we found so far. So we know that there was active volcanism as close as tens of kilometers, but I'm starting to wonder if there wasn't another volcano even closer. So on the property, we know we have north-south bounding faults that might be controlling the emplacement of the subvolcanic intrusion, which could still potentially be the heat source for the mineralization. And we also know on the American Creek project, a lot of the geological and geochemical features are typical for an intermediate sulfidation epithermal system hosted in intermediate rocks. So we have early Jurassic, subaerial, possibly subaqueous intermediate volcanic flows, volcaniclastic rocks, and associated volcanic sedimentary rocks, which likely formed in a dynamic, tectonically active, subduction-related environment. We also have seen hydrothermal breccias and stockworks, which suggest episodic conditions and multiple hydrothermal pulses. We've seen coliform and coccade banded veins that indicate repetitive veining and near surface conditions. And the sulfide assemblage and sulfur salt mineralogy that we see is consistent with intermediate sulfidation states. So we see galena, sphalerite, chalcopyrite, tetrahedrite, and locally acanthite and native silver. And that, in a nutshell, is our refined understanding of the American Creek project. So thank you so much for listening. See ya.